Welcome to your first podcast. This podcast will correspond with your guided study workbook for chemistry, topic 1, lesson 1. We won't get through the entire lesson within this podcast, but as previously discussed in class, make sure that you are writing notes on this podcast, as well as, and even more importantly, questions that you have on the podcast. So what is actually matter? What are types of matter? And what constitutes what matter is? Well, matter is anything that is going to have a volume, or it's going to take up some kind of space, because having volume means that you are able to take up space. Now, we might not be able to see air, but as you'll see in some of these videos, you can actually know that air is there even though it's invisible, because it will move something. So it obviously has matter. It will move something. You put a balloon in your face and it's going to blow air at you and make your hair go back or whatnot. The other aspect that has to be present in order for it to be considered matter, not only that it takes up space, but it also has mass. And it is capable for us to see easily that something like a pen or a pencil or a book or a chair or a car, that has mass for sure. It's heavy. But again, we're talking about air. Is air matter? Does it constitute, or does it fulfill both of those definitions? Does it have volume, and does it have mass? I want you to think about this question and how you would prove your answer to that question, whether air really is matter or not. How would you actually prove both of those instances, that it has both volume and mass, or that it only has one of them and therefore it does not constitute as matter? Once you have thought about that, you can watch these 3 videos over here that are linked, which are going to show you a little bit about, again, what matter is and if air is matter. Now, there are 2 types of matter. Matter can be either considered that it is pure, or it can be a mixture. So what I want to focus on with this podcast is pure matter. And within being pure matter, there are 2 parts of being pure. First of all, in order for something to be considered pure, you can only write it one way. There's no other way to write it. For example, if I wanted to write water down, the formula for water is H2O. I can't have H3O. If I have H3O, that's what we consider heavy water. That's not water. So if it's something that is pure, no matter what, it always is going to have the same name. It's going to have the same formula. Cu, copper, that's pure. No matter what, copper is going to be considered Cu on the periodic table. Now, for example, lasagna. Lasagna cannot be considered pure matter, because although you might have the same ingredients, it can be made differently. And I for sure know that my great-grandfather's lasagna was so much better, than my mother's lasagna. It is not the same no matter what. Now, when I wrote down the examples of the pure substances, such as water, or I can also write maybe CO2, or helium, or I can write down aluminum. There are some differences between these pure substances. They all can only be written one way, so they are pure, and their chemical composition does not vary. If I have aluminum, I have aluminum. Every aluminum atom looks the same. Every carbon dioxide atom looks the same. Every carbon dioxide compound looks the same. Every helium atom looks the same. But there are differences. So what are the differences between the 2 types of pure matter? Look at the screen right now and see if you can tell me. In here we have 3 substances, which are pure matter. 2 are one kind and 1 is of the other. I bet you could tell me what 2 are one kind and what the single one is, which one is different. But can you tell me why? In the previous slide, the helium and the aluminum, they were one type of pure substance, and that was that they were elements. If you are considered an element, all the atoms have to be the same. They cannot be broken down physically, or, this is most important, chemically. This is the only type of matter that cannot be broken down chemically. Okay. Physically meaning something like tearing or breaking or boiling or something like that. Chemically means reacting it with something. No matter what you react copper with, it's still going to be copper. Alright, the other thing about an element is that it is found on the periodic table. So that's why I can say copper is an element. I could say helium was an element. I could not say that carbon dioxide is an element because I do not see CO2 on here. I see C with a little o, but I do not see C and big O with a little 2, just call a subscript the little 2, on here. Therefore, it is not an element. So my question is gold an element? Well, yeah. Gold is a U, and it is on the periodic table right here. Is bronze an element? No, it's not. And the reason why is because bronze is not found on the periodic table. Bronze is actually a mixture. It's a mixture of elements put together that can actually be separated out again. So that's why it is not even a compound. It is actually a mixture. So elements, the big key is, if it's an element, it's on the periodic table of elements. Table of elements. Okay. So the other type of pure substance is a compound. A compound does not vary. It always is going to have the same name or the same formula. But the difference is, like previously, we said aluminum and helium, those were elements. Carbon dioxide was an example of a compound. And the reason why carbon dioxide is an example of a compound is because it's 2 or more different elements that are chemically combined together. You're going to see that they're chemically combined together because what you're going to see here is 2 or more capitals. So you got to be careful. If you saw something like this, that is not a compound. That is an element. It's called cobalt. But CO2, since it has 1, 2 different capital letters, it's going to be considered a compound, and it's chemically combined together. So you need to be very careful about elements that are 2 letters. The first one's capital, the second one is lowercase. It's only considered a compound if you have 2 or more capital letters. And it also says it has to have different elements. For instance, let me get rid of some of this here. For instance, if I have something that is this, which means it's got, say this is a hydrogen, and there's another hydrogen, and they're connected together. So I've got 2 hydrogens connected together. I've got 2 atoms, they're chemically combined. But because they're not different elements, this is not considered a compound, it's still considered an element. They have to be 2 or more different elements put together. That is a tricky question that might be asked later on, so just wanted to point that out. Compounds also can be broken down chemically. Remember previously that our pure compound, the element, could not be broken down chemically. Compounds can be broken down chemically. If you have a compound and you add another compound to it, they can react together and they can break apart. Elements cannot break apart. They also have a fixed ratio. Again, CO2 is always a 1:2 ratio of carbon to oxygen. If you had CO, that's no longer carbon dioxide, it's carbon monoxide, because it's only a 1:1 ratio. So the ratios, that's where this ratio thing comes, the ratios are fixed. They are what gives a compound its name, it's its identity. So all compounds will have a fixed ratios, and those ratios don't change. If the ratios change, it's a different compound. And lastly, properties of the compound are different than properties of the elements that make them up. In other words, and you're going to see a demonstration, or I want you to watch a demonstration which I have over here, in which they're going to combine iron and sulfur. You will see that iron, and you know that iron has a physical property such as magnetism, and in the next podcast we'll talk about different types of physical properties. But iron is magnetic, sulfur is not. So if I mix the two of those together, it'd be pretty easy for me to get the iron out. I just put a magnet over it and collect all the iron. But when I actually go ahead and I chemically combine the two of them together using some heat, I make something called iron sulfide. It's actually iron 2 sulfide. And in making iron 2 sulfide, it's not that I blend the two of these properties together, that this is magnetic and this is not magnetic, so this is somewhat not magnetic, it's kind of a blending, this right here. That's not the case. What actually happens is that this becomes its own thing. It gets its own properties. I can't really read that, but it says its own properties. In other words, iron's properties and sulfur's properties, you may take some of iron's, this iron sulfide, it may take some of sulfur's, it may take neither, it may completely change. When you do a chemical reaction between two elements and make a compound, those properties of that compound may or may not be the same, or some of the same, as the elements that make them up. So go ahead and watch that demo and you will see what I mean by that. And this should conclude the podcast, or your first podcast. And again, any questions, just let me know.